In this lesson, we're going to talk about rational numbers. Now, numbers can be grouped into subsets. You have natural numbers. Your examples are 1, 2, 3, 4, and they continue to go. And you also have whole numbers. The difference between your natural and whole numbers, the whole numbers contain the zero. Integers. Integers are examples that are on the board. It's -3, -2, -1, 0, and it continues on. Integers are all whole numbers and their opposites, and 0. So if somebody asks you what is an integer, it's every whole number and their opposites and 0. Then our next subset will be rational numbers. Rational number is a number that can be written in A, B form, which I've got in parentheses a fraction form, where A and B are integers and B can't be a 0. And then it is also a number that can be written as a quotient of two integers. So now we have the different subsets shown in a Venn diagram. You'll notice the subset, so the smallest subset is natural. Then you have whole, then you have integers, rational, and real. All numbers are real numbers. No matter what they are real numbers. So you'll notice we have indicated each of these numbers in a subset. Now, we're going to identify rational numbers. It says, show that the number is a rational number by writing it as a quotient of two integers. So in A, we have 7, and you're instructed to put it as a rational number using division. So you just put it 7 over 1. So in B, you would put it in a rational number, -10 over 1. C, we have C as the opposite of 3.5, or -3.5. So in C would be -7 over 2. Now, that fraction is a negative number. You can assign the negative sign to either the numerator or denominator. So will be the same as -7 over 2. The whole thing would be shown as negative. You can do, as we did before, -7 over 2 or 7 over -2. You can assign the negative sign to either one. So in D, 5 3/4, we would put that in a rational form, 23 over 4. Now, terminating and repeating decimals. If you take a rational number in the form of A over B and carry out the division of A over B, the quotient will either be a terminating decimal or a repeating decimal. So our first term is terminating decimal. That's when the division ends because you obtain a final remainder of 0. So in our example of 7/8, that's a fraction. A fraction is a part of a whole. So your answer will be in decimal form because it is part of a whole. So it is being in a division problem, we're going to take 7 and divide it by 8. So when you're instructed to take a rational number and put it in decimal form, you divide the numerator by the denominator. Notice, when we are dividing the numerator by the denominator, we have a remainder of 0. So it is considered a terminating decimal. Our next term, repeating decimal. It is a digit or block of digits in the quotient. It is a digit or block of digits in the quotient which repeats without end. So we have the fraction of 2 over 3. Let's divide 2 divided by 3 if you do not know that. Well, this is one of the fractions that you should know and have it memorized. We discussed earlier in the class. Go ahead, though, and show it. 2 divided by 3. You are going to notice a pattern in this, noticing that the 6 repeats. Since the 6 repeats, this is a repeating decimal, you indicate that by putting the bar notation, the bar only over the number that repeats. So that is the correct way of putting 2/3 in a decimal. Now you're asked writing fractions as decimals. Write the fraction as a decimal and tell whether it is a terminating or repeating decimal. I'm going to pause the video. I'm going to ask for you to work these out. We'll come back and check your answer in the decimal form and if it's a terminating or a repeating. So notice when we take 3/8 and are asked to put it in decimal form, we take 3 divided by 8, and we notice that it is a terminating decimal. It is a terminating decimal so that when we divide, the remainder is 0. So 3/8 is equal to 0.375. I'm going to ask you to remember to put a 0 in, or a placeholder in the 1 spot. 5/11. It is equal to 0.45, bar notation over the 4 and the 5 because those are the 2 digits that repeat. When you use a bar notation to show which digit or digits repeat, be sure to put the bar over only the repeating digits. So in this example, note you just put the bar notation over the 5. And on the next example, the bar notation goes directly over the 6 and the 7, and only those two, because that is what repeats. Now in our example, using decimals to compare fractions. Of the 50 mammal species found in the Canyonlands National Park, 20 species belong to the order of Rodentia. Of the 54 species found in the Badlands National Park, 24 belong in the Rodentia. In which park is the fraction of mammal species belonging to Rodentia greater? Now, Rodentia is a type of species, and it's a type of animal. So we're going to put each of these in ratios or fractions. Then from fractions, we're going to put them in decimals to compare which species is the greater. So I abbreviated the Canyonlands National Park to C. There were 20 out of the 50 mammal species for the Rodentia, and I reduced that fraction, simplified it to 2/5. Then I took and I divided 2 divided by 5, and I got 4/10. So that is 2/5 in decimal form. Then I took the Badlands National Park ratio, 24 out of 54 were the Rodentia. I simplified that to 4/9. Then I divided 4 divided by 9, 4 divided by 9. Notice that the 4 is repeating. So I put the bar notation over only the 4. You need to be really careful as I need to change that. Now we're going to compare 4/10 to 4/10 with the bar notation over it. Note on the 4/10 that this have invisible zeros after it. And on the one with the bar notation, that would be 4s continuing. So the Canyonlands would be less than the Badlands. So the question is asking which fraction is the greater. And I'm going to circle the Badlands National Park because its fraction of 24 over 54 was the greater of the two once we put them in decimal form and compare. Now we're asked to write in decimals and fractions. To write a terminating decimal as a fraction or mixed number, use the place of the last digit to determine the denominator of the fraction. So in this example, of example 4, we have 7/10. 7 is in the tenths place, so we can indicate it in fraction form just like that. In B, we have -3 and 5/100ths. Because the 5 is in the hundredths place, you can reduce that to -3 and 1 over 20. There are common fraction decimal equivalents that you would just need to have memorized. So when you have 1/2, putting it in a decimal would be 0.55 1/4 is 25/100ths. 1/8 is 125 thousandths. 1/3, 0.3 with the bar notation over the 3, and 2/3 then would be 6/10 with a bar notation over the 6. When writing fractions as decimals, what is the pattern when the denominator is 9? Note when you have the fraction 2 over 9. If I was to divide 2 divided by 9, notice that the numerator repeats. So 2/9 in decimal is 0.2 with a bar notation over the 2. Another example, 4/9. If I was to divide 4 divided by 9, the 4 repeats. And again, the numerator repeats when the denominator is 9. So let's look at the next example. When writing fractions as decimals, what is the pattern when the denominator is 99? It is the same rule, only that, again, the numerator repeats itself. So when you divide 17 divided by 99, 0.17, bar notation over the 7. When it has a denominator of 99, 22/100ths with a bar notation over the 22. So, note, when the denominator is 9, the numerator repeats itself. When the denominator is 99, the numerator repeats itself. Ordering rational numbers. We're asked to order these numbers from least to greatest. So, we're going to put them all in decimal form. But there are a couple of steps we'll have to do before that. We are going to change the improper fractions to mixed numbers. -1 and 1/4 will be the same as -1 and 25/100ths. We already have this in decimal form, -0.2. Then we have 4 and 31/100ths. Then -3. So now we have 5 over 2, which is going to be 2 and 1/2, which in decimal form would be 2.5. Then I have 13/3. -13/3 is going to be equal to -4 and 1/3. And as we had discussed earlier, that would be equal to 4 and 3/10 with a bar notation. Now, we're going to compare our decimals and order them from least to greatest, putting them back in the original format. So as I'm looking, I'm noticing that -4 and 3/10 with a bar notation is the smallest, so I'm going to put the answer back in the original format. If it helps, you can mark through once you've used it. Now, the next one, if I compare the decimals, would be -3. And as I'm looking, -1 and 25/100ths. will be next. 2.5, which is 5 over 2. And lastly, 4 and 31/100. So when we're giving numbers, put them in the decimal form, look at them, and then order them from least to greatest.